Guys, welcome back to my math YouTube channel. I'm back with another example here where we have to convert from a standard form of a complex number to a polar form, or we also like to call the polar form as a trig form. So guys, the very first step that one has to do here is to first identify the real part and the imaginary part, and then we actually start by plotting the complex number. So in this case, we have the real part, which we usually like to identify by A, is -3 radical 2. This is my real part, and then my imaginary part in this case is also the same, -3 radical 2, and that is my imaginary part. Guys, once we identify this, now we are going to go ahead and we are going to plot this point, and I'm going to draw my complex plane where this is my real axis, this is my imaginary axis, and let us plot the point A, -3 radical 3, and B, -3 radical 3 radical 2 and -3 radical 2. First of all, let me rewrite this as a coordinate pair. It is -3 radical 2 and -3 radical 2. Now, transferring this information onto the complex plane, it is going to be on the left hand side, both these values. So I have to go -3 radical 2 on the left and then down -3 radical 2. So it's going to be somewhere right here. And once I have my complex number, z equals to -3 radical 2 minus 3 radical 2i, or you can also write this as a coordinate pair. Okay, now we can go ahead and actually join this complex number, this point, with the origin. And guys, once we join this, now we know the angle that we are talking about here is going to be this angle right here. This whole angle is going to be my angle. Let us call this angle theta. But for convenience purposes, guys, we can actually drop a perpendicular from this point onto the horizontal or to the real axis. So let us go ahead and do that. Okay, this is my 90 degrees. So guys, based on the given information, this is -3 radical 2. This is also -3 radical 2. Keep in mind, these are the x and y coordinates, not exactly the lengths. Right, we know that from the basics of finding the ratios, the basic trig ratios for any given angle. And then guys, based on this right triangle, this is the angle theta. Sometimes we also like to think of this reference angle as angle theta. And then guys, we have to first evaluate the hypotenuse, or this length, right? Or we usually call it r. So let us first go ahead and evaluate that r, because in order to write the polar form, we need r and then we need the angle theta. So polar form is the trig form, which involves the r, which is the absolute value, or the radius, if you like to think of this as a circle, or you can also think of that as an absolute value, or in this case, if you just think of this as a right triangle, then guys, this is the hypotenuse, and then we need the theta. So to find those, first of all, we have to set this up. Once we have it set it up as a right triangle, it is very easy to just use the Pythagorean theorem and find the value for r. Once we have the r, then we will try to find the value for the angle theta. Okay, so we know r square is going to be this side square plus the other side square, so it is -3 radical 2 square plus -3 radical 2 whole square. And to find r, we just have to simply take the square root. So let us go ahead and take the square root of this. Guys, taking the square root, I'm already going to simplify this. -3 squared is 9, and 9 times 2 is 18. So both of these are going to be 18 and 18. 18 plus 18 is 36, so it is radical 36. When we simplify this, we get 6. So our r is 6. Now let us go ahead and try to find the try to find the theta. So guys, we know to find the value for the theta, we start by first finding the sine of theta. And we know sine of theta is the y over r. You can also think of that as the opposite over the hypotenuse. But when we when we are defining these for angles greater than 90 degrees, then we prefer using the y, x, and r type of a notation. So y over r, guys, here we already have the y value, which is -3 radical 2. And you got to divide by r, which we already found out to be 6. So we simplify this and let us see what we get. -3 and 6 will simplify to just -2 radical 2 over 2. So that is the value for the sine theta. Similarly, we got to find the value for the cosine theta. And we know the definition for the cosine is the x over r. So x over r, what is my x value? It is -3 radical 2. So we're going to replace x with -3 radical 2. And then guys, this has to be divided by 6 again because r is still 6. And when we simplify, 3 and 6 simplifies as -1/2. So we're only left with negative radical 2 over 2. So we have sine theta and cosine theta, and we can also see that this is in the third quadrant. In the third quadrant, only tangent is positive. So it also satisfies that condition that in the third quadrant, both sine and cosine are negative, and that's what we are getting here. Both are negatives. So now we go into the unit circle. We look at the unit circle and we try to figure out for what angle theta do we get sine and cosine to be negative radical 2 over 2, and both are basically the same. And the value for that is, I'm looking at my notes for that, it is 225. So when I look at the unit circle, so I looked at the unit circle, and from there we could see that the angle is 225 degrees. So that is the theta. Guys, we have the theta, we have the r. Let us go back and write the polar form or the trig form for this standard form. Okay, so I'm going to get rid of this so that we can write the polar form. First of all, guys, the polar form looks like this. It is r times the sine of theta plus this is cosine of theta first. Cosine of theta plus I sine of theta. That is the general way of writing the polar form or the trig form. And now we have our value for theta and r. So our answer for this example would be, and let us put that in a box. This is going to be r, what is r? 6. Okay, got to write 6. And then there's cosine of 225 degrees, 225 degrees plus I sine of the same thing, sine of 225 degrees. This would be the polar form for this example. Guys, example 2 is done. I will see you next time with example 3 and 4. Till then, guys, take care. See you next time.